This is a molecular model that I just printed with my new 3D printer, a Bambu X1 carbon, which is utterly fantastic. I have 2 AMS units, so I can have up to 8 filaments. And this is one of the reasons why I bought this specific printer. I've been looking at doing multi-filament. This particular model, this is actually from crystallographic data. This is a compound that one of my students made. This is an iron, that's gallium, green is chlorine, black is carbon, so these are carbon monoxide, and these are called cyclopentadiene rings. So the relative positions of all of these atoms is based on actual data. So this is not like a molecular model kit that you buy for general chemistry or something like that. So that's what's really amazing about this, to be able to take actual data and then print it out, and not just have it in one color, to actually have each of the elements represented with different colors. Really is useful when you're trying to explain what you're doing. So again, black is carbon, white is hydrogen. So this is an organic cyclopentadiene ring right there. In this case, I made yellow iron. Again, carbon, oxygen, so those are carbon monoxides. That's gallium, and there's an iron-gallium bond. And then there are chlorines, a terminal chlorine, and then bridging chlorines between the galliums. And then we have the other side of the molecule. There's an inversion center right in the middle. So having this chemistry resource is incredibly valuable. And you can make really cool stuff like that. So I use these kind of stands for holding little glass sculptures and give them out to students, but they're always monochromic. They're always just one solid color, but now with this printer you can do ridiculous stuff like that.